In this tutorial, I'll be going over how you set up a regular aircraft using just the blueprints. I'll be demonstrating how you start and finish the setup using the Boeing 737, and unlike before, I won't be using the datasmith like model. I'll just be using a standard FBX. If I drag and drop that and say import all of this, what else do I need? I just import smithing groups and just some general ones. So this is a standard fuselage. It's a really low poly model because again, I'm not really interested in like the level of fidelity for the model. It doesn't affect the system in any way. It's just for visual purposes. So I have the fuselage, then the right, like some of the wheels I want to demonstrate how you use like blueprint connections to get them set up. If I go to where the scripts are stored and we go to the point and create a blueprint based on that and put it in here, and it's a Boeing 737. All right, so all the base stuff is created by default. Now say you wanted like what is it called, the root component to be a skeletal mesh, or for example you want to add a skeletal mesh. This is a skeletal mesh and you can like configure the mesh however you want. But say you want your skeletal mesh to be the root object because the base root that comes with the system is a static mesh, which is just a normal cube. You can actually go to the script and then override the constructor to create your skeletal mesh here and set it at the root. So basically what I do is I create the cube, set it as a root component, and then set the physics settings here. So say you wanted any other kind of, so like, you know, any other kind of mesh, all you have to do is just override the constructor in the aircraft control system, and then you'd have your what is it called, your required mesh here, and you can just continue the setup process. So one of the things that get created is just the cameras that you need. Like I said before, you can replace this with like the spring arm cameras, but this is probably the really important one. That is a general aircraft controller, and this is what you should attach the other aircraft components to. So if I create a static mesh here and just name this the fuselage, and then drag in the Boeing fuselage. This is, I think it's 90, then just zoom out. It's not, is it oriented properly? I don't think so. No. So it needs to rotate to the left by 90 degrees so that the forward axis of the aircraft, the nose of the aircraft, is pointing along the aircraft forward direction. Then I also want to move this down a bit so that the center of the controller is roughly at the center of the mesh. This is not like a requirement, this is just going to make it easier to like configure the center of gravity and all the other like aircraft transform components. Then yeah, I think this is perfect. One thing you can do before you start the setup process is go to the editor tab on the model controller, and then you can increase the thickness of the lines and the gizmos that will be drawn. So depending on the size of your aircraft, that might make it easier to like see where each component is positioned. So maybe like 3 is enough. Yeah, that's enough. So if I look at this from the left, I want to drop my, and then I go to the avionics section. I want to drop my center of gravity just down a little bit and move it forward just a bit. Yeah, okay, there is good. And then I need to set the inertial property. So IXX is roll, IYY is pitch, IZZ is yaw. So for this aircraft, it's about 21919, and then this is 74,000, and this is 82,000. And then the empty mass for this aircraft, if I go here, it's 29,620. So 29,620 kilograms. And then the tensor will be updated here once the system starts. Then before I leave the avionics, I want to set up the fuel tanks. So if I add two components and then set the type to fuel and change this back to perspective, I want, again, you can go really wild with this, but for this demonstration, I'll just use like really basic inboard wing tanks. And then I position them here, move them forward slightly. And this is 18,850 kilograms. And if I copy this, paste, and then I invert the y-axis so that it's just on the left. All right. So now we have our fuel tanks, we have our center of gravity. One other thing I need to do here before I move is the camera. If I expand the model camera and then the focus point, that is roughly here. That's going to be this center. So that was why I wanted to position this at roughly the center of the mesh, because the camera is just going to rotate smoothly around the mesh. Then the head of the pilot, for this model, I don't really have like a detailed cockpit or anything like that. But if you do, you can use this to set where the internal camera will be positioned when you switch to cockpit view. That line, that gizmo is drawing where the head of the pilot is supposed to be positioned. Anything else on the on the avionics? I think that's fine. Maybe I increase this to like 35. So this is the distance behind the focus point where the camera will be positioned. So we can adjust this data. So let's just leave it like this now. So save and compile. All of this is fine. And then if we start with the wheels, add component, and then add a scene component that is just a container. So we say this is our wheels, and then I add the wheel component. So this is front. I won't be creating like the really detailed wheels, to be honest, because it's the exact same process for all of them. So I'll be using, I should use wheels here. So front, you know what? Now let's just do it. So left wheel. So if I move that to roughly where the mesh is positioned, I have a dedicated video. I think that was the last one. That is just going over the properties of the wheel and how you set it up. So you can watch that too for like a more detailed explanation of what each of these properties, what the properties actually do. But for this, we'll just be focused on setting them up for this aircraft. And then stroke is a little bit more, and then stiffness is I think 120,000, and this is 23,500. Then I'll be showing how you can use the regular blueprint system to configure those wheel, the mesh, which is supposed to be displayed for the wheels. So if you don't want to set it up using this, you can actually set it up entirely using the blueprints. So this is the right hand side, so right wheel, and then I move it to the left, and I create a wheel and say this is the left rear wheel. So honestly, I'm just going to create one giant wheel instead of creating two small wheels. That might be bad, but I guess we'll find out. Because I'm just trying to speed run this process. So if I put it at the center here, then I make it really wide and increase the stroke. So I'll command it for that. I think that fits nicer. Yeah, it's about 48. 0.48 meters is the radius, and then this is 235,000 with 45,600 for the damper coefficient. And then I duplicate this and move it to the right. So right rear wheel, and then I invert the y-axis. I select them. All right. Again, you shouldn't really do this. You should set up individual wheels for each one of the mesh you have. But because I've already explained what the wheel does, and this is just to show how you can set up the aircraft here. I'm not really focusing too much on like the actual detail of the setup. So now that the wheels are done, the next thing is the propulsion system. If I add another, well, you know what, I might just add the power plants directly. So Silantro power, and then we say left engine. Okay. Do I really have, oh, this is perfect. I already have a CFM aircraft, a CFM engine. So CFM 56, I think that's the one on the extended one. So that might actually be slightly too powerful for this aircraft, but not by much. 117 kilonewtons to, woohoo! Oh, that's 69. Oh, that's half. Okay, what we could do is, if I select this, and then this is not a propeller, but this is pushing backwards, and then I can set this and move the force point offset. This is where the force generated by the engine is applied to the aircraft. So you want to position this roughly where the engine nozzle is. So somewhere around there. Okay. So there will be another tutorial that just explains the propulsion system and how you set up like different kinds of engines. There is no propeller here, so the inlet position is also, if I copy this and paste it here, but then I push it forwards because the inlet is somewhere here. All right, that's good. Yeah, that's good. And then I copy this, and that's right engine, and I just offset the y and z, the y positions for the inlet and engine nozzle. And then if I just select all the components to see that everything is still configured properly, yeah. So now we have the engine nozzles positioned properly. We have the wheels. Those are looking nice. Then before I go further, I want to add the flight control system. I won't be going into detail with this, but it's required for the aircraft to actually function, because this is the thing that processes the controls that you're sending to the aircraft. So it's not augmented. We'll be starting with manual, where we're just moving the aircraft control surfaces directly, and then we start adding like different levels of augmentation. What else? Okay, I remember this. If I go back to the pawn, and honestly, this is why I don't like setting it up here. So for example, if I show you what this looks like in the general editor, This is so, I mean, I guess I could do it, to be honest. I could like design this a custom details panel, but I like the fact that this is done by default with this tab system where everything is just neatly arranged. I guess I'll have to do it manually. So if I delete this and we go back to the blueprints, viewport, and while the pawn is still selected, we should scroll down to the auto process player. We want player 0, and then we want to receive inputs from player 0 by default. Is this here? Then world partition system specially loaded off, so that it doesn't constrain us into like a point on the map. I think that's it for the control system. What else is left? Okay, so now we can start adding the wings. So if I add another scene component to be a container, the dynamics, and in here we add a surface, and this is going to be our wings. And I go to top view. That's nice. And then I can scale this to match my aircraft. Yeah, roughly around there. And then if it gets left view, it needs to come down a little bit. If I go back to perspective, position somewhere here, and then increase the root chord. That's a little bit too high. Maybe here. Nah, that's too much. If you scale it back down a little bit. All right, I think that's good. So we want uniform distribution. It's double surfaces. This is a wing. We want to reduce our taper ratio a little bit and then sweep backwards. So I actually need to scale this. It gets here. Yeah, that's good. And then I can move this forwards. So what I want is the trailing edge of the middle point should actually line up with the trailing edge of the mesh. And then if you imagine that there is a point where the left and right wings are going to meet in the aircraft fuselage, you want the root leading edge to actually be positioned there. So I think this is good enough. And then we're going to use the panel system to match the shape of the wing, because we're not going to match it by default with this. So this wing has a little bit of dihedral, so I think that's the next thing we want to set up. But before we get there, I want to increase the root incidence a little bit, because the wings are pitched up, I think, yeah, 3 degrees. We'll start with 3 degrees, and if I go to front view and I reposition the wing here, and then I start increasing the dihedral to a point where they actually match. 7 degrees. 7.3 degrees. Okay, that looks good. And then go back to perspective. So that looks like a really good match. Feels a little bit too low though, so bring it up a little bit. And then scale back the span to match the new wing shape. Ah, perfect. Okay, that looks nice from all the angles. Okay, so now we can start cutting things up. So if I increase like the semi-span count to like 10, so that I have enough points along each. Still feels like I don't have enough though, so maybe 12. Yeah, so I want 1 point along this point. I mean, along the, to match with the position where like the sweep of the wing actually changes. So that is going to help me with the setup. So if I go to if I close surface and go to panels and then expand the panel correction, so this goes from root to tip. So 0 is the root point, and then 11 is this one at the tip. So this goes from root to tip. So we start making like adjustments to the chord sweep and the hydro to make sure that we can match the shape of the wing. So I think 0 is fine. 1 is where we want to start changing things. So that, and then I sweep it forwards a little bit. Oh, good. And then 2. It feels like this is too much. If I relax this a little bit, and then I can tighten this up. Yeah, good. And then I move to 3. Number 4. And then number 4. And we sweep it backwards just a little bit. This is interesting. I want to increase this and then sweep. Slightly. Okay. And then the next one, I want to increase the chord a little bit and then sweep forwards also by a little bit. Okay. And then I think all these other ones actually look okay. So it's just adjusting the sweep towards the edges. Yeah. All right, good. So I think we have a really good match here. So it looks okay. It looks okay from the front. Looks good here. All right, that's actually a really good match. Let's go. So if I go back to the surface, extensions, no, aerofoils. So at the root, I think I'm using the supercritical aerofoil, and then I want to use the 13% one at the tip. You can always start with like one of the default wings if you're not sure of which particular aerofoil is used on the wing, and then you can like start adjusting them once you start flying to see like, you know, does it work, or do you need more performance or a different kind of aerofoil. If I move this a little bit towards right, and then increase the root and tip chord for the ailerons. Actuators, because again 60% is, 60 degrees per second might be too fast. I think it's about 40 degrees a second. I might be wrong about this, but you can always experiment and see which one works best for your setup. So I don't have like mesh hinges here, so I'm not gonna worry about that. Then the flaps here might actually be a little bit complicated, but let's see if this works. And then if I increase the root and tip fractions just to match that shape. Okay, and then how many settings I have? I think I have like 5. So 0, 5, 8, 15, 22. this isn't like the actual settings I used on the real aircraft. These are just the basic ones I always start with. Actuators. Okay, I'm also going to set this. Well, this is really slow, to be honest. Well, 20 might be too fast, but we'll probably adjust it later. So this aircraft actually uses spoilerons. In addition to the ailerons to control the roll axis. So if I activate the aileron and the spoilers, and then switch the operation mode from normal to spoileron, so that I can use them together with my ailerons for roll control. It's roughly at the midpoint of the wing. And then I scale this back, yeah, and then I increase the root and tip chord fraction a little bit. Yeah, I think that's about right. Okay. Inch fraction. So because this is a floating surface, you can actually shift where the hinge is located. So if you can move this backwards or forwards, but I think this is roughly around like 55% in front. Yeah. The actuator, I'm going to leave this at 50 degrees a second. Deflection limit is about 52 degrees, I think. And then coupling is how much of like the normalized aileron controls are sent here as part of the roll control. So if you think about it, I have, where is my deflection limit? I have 52 degrees. So how much of the specified maximum deflection, that's 52 degrees, how much of that can be used for aileron control? So if you said 50 degrees, that means only half of the 52 degrees will be used as part of like the roll control. So if I increase this to like 100%, that means I can deflect my ailerons upwards for a total of 52 degrees as part of like the aileron controls, but that's too much. So I think I'll leave it at 50 degrees and we'll come back if that feels too much. So save and compile. And then if I add another surface, I call this horizontal. And switch back to top. Go back to move. Where is move? And then move this backwards. Align this here. And then I scale this. If I switch to front view, I'm gonna need to move this up and increase the dihedral. So, oh no, before I get there, we're still using uniform. It's double pane, 2 sides, but this is now a stabilizer. If I then start to increase the dihedral to match the shape of the mesh I have here, so this is I think 7.5 degrees now. Nah, 7.8 degrees. 8 degrees, okay, fine. We'll set it at 8. And if I switch back to top view, and we sweep the wing backwards, move this forwards a little bit, and then increase the semi-span. All right, that's good. The taper ratio, reduce that. So the other match is really nice. I want to use symmetrical aerofoils on this though, so let's say the 15% one. We have control surface here. This is the elevators. We have uniform deflection because both of these are deflecting in the same directions. On the wings, they're in the opposite direction because one aileron goes up and the other one goes down. So this is uniform, and then the entire aircraft surface, the entire span is covered by, let's say it's the entire surface is covered by the control surface. And then if I zoom in here, I can actually really match the root and tip chord fractions. And I drop this down a little bit. Yeah, okay. That should run good. Let's set this to 50 degrees a second and leave the default values there. You can always come back and set them again if you're not, like, satisfied with the kind of controls you're getting from your aircraft. And then if I add the vertical stabilizer, this is uniform spacing still, but this is now a single pane and it's a stabilizer that has a dihedral of 90 degrees. If I change to left view, and then I can move this here, and then if I zoom in and scale the root chord, and then increase the span and sweep the wing backwards. So we actually have a lot of customization to do here to make this fit. So we want it to fit at the back first, okay? And then reduce the taper ratio of, let's say, and then increase this to 10. We also want to use symmetrical aerofoil on this. No, wait, on this. So before we get to the control surface, I want to go to the panels and like set the shape properly. So if I start at the root, and then I start like pinching it a little bit. If I sweep backwards up to here, and then decrease the chord fraction, and I try to sweep this, not too much though, reduces the chord fraction, good. And then more sweep, reduce the chord fraction. Oh, this one looks like this is still too much. Yeah, okay, that's good. And sweep to the next one and release the constraint on this. Nah, that's fine. Okay, so and then we release this a little bit and sweep it forwards. Yeah. And then release this also. Maybe not so much. Release this. Sweep backwards. And then release this. And sweep back to the front. Yeah. And then release this. I think the sweep for this is fine. And then the last section we want to release and leave there. So like I said, you don't have to worry about the fact that this doesn't get to the edge of the surface. There is a panel here. This is representing the main chord of that panel. So you're not actually looking at the panel, you're looking at the main chord of the panel. What next? Okay, the next thing is the control surface. This is active. We have the rudder surface here. We want to drop this, I think, to 0. Yeah. And increase the chord fraction. Where is all right, this is it. It's here. And then drop this a little bit so that it lines up. Yeah, all right, that's good. So if I check all the surfaces that I've just configured to see that everything works okay. Perspective. All right, that looks good. Let's see if we try to fly this, if it's gonna work. It should work, but you never know until you try. So if I set this down, Yeah. And then I play. I don't know why. So because my static mesh has collision on it, it's going to be interfering with my regular wheel. What is it called? Because the wheel is using a sphere cast, and given the fact that you have collision on the fuselage static mesh, it's going to be interfering with it. So what you actually want to do is set up a collision preset and add the layer where your static mesh is as one of the layers that will be ignored by the wheel. But since I'm not really interested in like the collision in here, I'm just going to say I don't want collision on the static mesh. Ideally, what you should do is like use this. It's kind of like the collision layer ignore thing in Unity. So you want the wheel to ignore collision on like specific layers here. But then if I go back, so now my wheels are working, but I don't have controls. That's good, but everything at least looks okay. So if I go back to my blueprint and go back to the control system, I think I made that change in, where was it? No, you know what? I could do this here. I made that change in, I think 1.05. So now you have the enhanced input system where you can connect your input systems to. So I want to use the enhanced input, not the default input, and then I'm going to be using my keyboard. So I'm going to set this to press inputs. If I'm using a controller, say like a joystick, you want to set that to like a continuous input because the input there is continuous, but on the keyboard you have to press down the button for the aircraft to move. So if I select the control context I want to use the keyboard one, and then I select the stick action, control stick, pedal control action. I search for pedal. So these are control actions that you can actually configure. So you can, because they are just standard on rail enhanced input systems, you can configure them as you wish. And if you go to like the context, you can then set the bindings for each of your controls. So I think I have one for, where is it stored again? It's in the plugin folder, inputs, and you see the context. So this is the one for the control system where I bind it to the generic controller from the Windows raw input, but we're using the keyboard for this test. So if I search for throttle control, and then if I expand general keyboard, you see all the action bindings for each one of these actions. I genuinely wish this on physical objects, but you know, it is how it is. So start engine, stop engine, brake, lower flap, raise flap, camera, and yeah. And then we want to set the mouse action. So left mouse button, mouse scroll wheel, and then the look axis. So that is the thing. So then you can change like the speed of actuation for the keyboard actions. So the first, this is a vector. So the first one, this is the x-axis is for the positive, y-axis is for the negative, and z-axis is if this is a control that goes back to neutral, how fast does it go back to neutral. So if I repeat that, x-axis is how fast does it move from the current control state to the positive maximum, Y-axis is how fast does it go towards the negative axis, and Z-axis is how fast does it go back to neutral. So throttle axis is set here, but you know, it doesn't go back to neutral, so it doesn't have any effect on there. And then here is where you can invert either of those axes. So if you've configured your joystick in such a way that the axes are inverted, or you find out that the axes are inverted, instead of going to the script like at the -1, you can just toggle one of this to see if they to invert a specific actions, and then these are just debugs for you to see what is happening. So now I have mouse controls, and then again, so this is in the cockpit view, but this is a very low poly mesh, so I don't have a cockpit for this. It does feel like the rear wheels are a little bit too high though, like the stroke on the rear wheels are a little bit too high. So if I go back to the blueprints, right rear wheel, and then I reduce the stroke to maybe 48 centimeters, compile, save, and then oh yeah, all right, that looks better because now the nose is aligned. It was behaving like as if it was like nose heavy before, so I think this is ready to test. If I check my keyboard actions, yep, they're working properly. So QE is rudder axis, W and S is keyboard, A and D is aileron. But because again this is a static mesh, so I didn't configure the control surface, so we can actually see the control surface is moving. If I escape this and use like a full screen, what is it again? New editor window. So B to toggle the brakes. We want to start the engines. Why is it? All right, the throttle is inverted. Okay. Because I was wondering why it was starting at 100%. So toggle the brakes, start the engines, and then we can increase throttle. And the pitch is inverted too. Nice. Toggle brakes again, start, throttle up. Whoa. What the hell is that? All right, the wings are stalling. Oh my god, I think there was a problem with the airfoil that I configured. So this stall angle is ridiculously low for some reason. Yeah. So if I go back to the blueprint and use some generic airfoil at the root. S2313, that's 14 degrees. Which one do I have it there? This is not an airfoil that you use on this aircraft, but because this is a demonstration exercise, I didn't want to like go too deep into like the airfoil selection or things like that. So let's try this. Start release brakes, start engines, throttle up. Oh, nice. So now we're able to fly. So before, what was happening is because the stall angle was just so low, that's supercritical airfoil. There was a mistake with the setup process, so I'll have to reset this up. So it was stalling at like 9 degrees. That's way too low. So that was why by what was happening is on takeoff, the left wing was stalling before we even like get some positive climb rate. So now what else do I want to set up? All right, yeah. So one other thing I wanted to show before I finish this is how do you collect information from the C++ components and use your standard blueprint, methods? Because it seems a lot of people are like, really into using blueprint, but that's fine. So I'm going to add a demo sample. That's why I removed the mesh on the right wheels, because I want to show how you can use blueprints to add a wheel mesh or like a surface mesh, whatever mesh you want. Let's assume this is the wheel mesh that you want to use, and let's call it right wheel mesh. Again, I'm using a queue because that's just a default object and it's a default static mesh. So I don't want someone to look at this and think, oh, it has to be that specific component. No, it can be any mesh that you want. So you like, okay, and then if I go back to the event graph, so the first thing I want to do is I need to get on my wheel component, there is a function called get world mesh location. So I want to get it from the right wheel. And then there is another function called get local mesh rotation, and also get that from the right wheel. So if I remove this, delete this, and then I connect this to this, okay, and then I put this here so that I can just connect them together. And this is going to be happening in Inventic. So this gives you the position where the wheel mesh is supposed to be positioned. There is still a slight bug with this, but I'll fix that later. So this returns a vector3, which is in world space. That's where your mesh should be positioned. And then this returns a cotangent, which is, the local rotation that you want to add to your mesh. So the function that we want is called set world location. And we want to do that for the right wheel mesh. And then we want another one called, you know what, let's connect this. And honestly, this is, well, I won't start ranting about why I don't like blueprints here, but yeah. So, and then we connect this. Let's put this here. So we set the world location here. I'm already okay. And then the next one is add local rotation. We want to do that to our right wheel mesh. So since I already have this here, I can just connect this to this, and the output is the one we got from here. So basically what is going to happen now is from our right wheel component, which is written in C++ here, this, we get this function. And if I show you where the function comes from, it's towards the base here. So these are the functions. All of this you can call from your regular your standard blueprint. So you can even like disconnect all the all the connections I have for the pawn and run everything entirely from your blueprint. So there is a function here that says initialize. This is how you set up the wheel. Then you have to call this every single time you update the physics. So you can get and set all of those components. So you have the same thing for, where is this? So if you go down towards the surface script, you have a lot of this. So you can even get like the current deflection for each of the control surface and set them from your blueprint. So they're all here. You don't have to use like the, what is it called, the C++ components for everything. You already have like blueprint callable functions and systems here that are already provided that you can connect to your blueprint project. If I save this, and then now if I play, All right, that collision thing is happening again. So if I go to my cube, where is it? Mesh, and then just disable collision, because remember the wheel is using a sphere cast, so it's not just a ray cast, it's a sphere cast that has the radius is designed to match the radius that you configure here. So you have to move all of the mesh that you don't want interacting with the wheel component to a different layer, and then tell the wheel to ignore those layers. So now you can see that our cube is positioned where the wheel is supposed to be. So now if I release the brakes and start the engines, and if I throttle up, you can see that my wheel is rotating. So we've just added, instead of using the wheel mesh that is configured from C++, which is what I would advise you use, you can still connect everything to like your standard, blueprints that you were using before. Yeah. All right, I think that's it. The next video will be going over how to configure the Aero-surface system. I just need to get some time to record that. All right.